Good morning, everyone, or good afternoon, depending on where you are. I have with me Thomas Greybeck, and without further ado, I'm gonna give him the rein of the presentation. Thank you very much for being here.
Thank you so much. And it's both me and my colleague Albert. So there. So we're from Graphisoft Center Denmark, a small company, and we are the local resellers of Graphisoft products in Denmark, and we are also the producers of the Design LCA software. My name is Thomas Greybeck. I'm an architect by profession, but the last 12 years, 15 years, I've been working as a software guy instead. And the last 5 years, I had my own company, dealing Graphisoft, training, supporting, and lately it's been a lot about sustainability consulting. So that's great.
And my name is Alberte, and I am a student worker here at Graphisoft Center Denmark. I am studying a civil engineering degree in architectural engineering at the Technical University of Denmark. And I finished my bachelor's here during Christmas. And after Christmas, I will continue on my master's, where my studies will focus on sustainability and building information modeling.
And your bachelor's assignment is actually about reusing concrete elements.
Yeah, exactly.
So that's also part of this sustainability thing.
Yeah. And so for the next 15 minutes or so, I will give some context to what Thomas will talk about later. I will briefly touch on the role that the construction industry plays and in the climate context. And then I will dive deeper into building regulations and LCA requirements, particularly from a Danish point of view or from. So as we can see here, the construction industry emits a lot of greenhouse gases. So the construction industry accounts for about 40% of the global emissions, which is a substantial share when thinking about that remaining 60% are all other sectors. And in Denmark, we see the same pattern here. The construction industry accounts for 30%, which is also a substantial share. So there's really no doubt that the construction industry needs to change its ways in order for us to minimize the overall greenhouse gas emissions. And in Denmark, we do in fact have building regulations that aims at minimizing emissions from the construction industry. Many of these regulations, they are based on initiatives from the European Union, and these initiatives from the European Union, they are aiming at minimizing the overall greenhouse gas emissions in among the European countries. So I will just mention 3 of the European or the EU initiatives, and the first one is the Green Deal. And this is a strategy where the overall goal is to reach climate neutrality by 2050. Another initiative is Fit for 55, which is a legislative tool where the overall goal is to reduce the greenhouse gas emissions by at least 55% by 2030. So that's kind of a stepping stone to reach the Green Deal goals. And the last initiative is the EU taxonomy, which is a financial tool that aims at steering investments towards more economically sustainable projects and activities.
And that's already, it's not effective for buildings yet, but for other things. So if you want to buy a car and you want to have a bank loan, the bank loan will be cheaper if you buy an electric car than a fossil fuel car. And in a few years from now, this will be the same with buildings. If you have a sustainable building, if there's such a thing, then you can get a better loan and perhaps a better financial agreement with your banks. And that's a great way of making sure by following the money that this gets effective.
Yeah. So this map shows us how different European countries are adopting environmental regulations for buildings. And this is specifically focused on whole life cycle carbon, which is the the carbon that buildings emit throughout its whole life cycle. And all the dark orange countries on this map are the ones where there is implemented regulations on all non-residential buildings. This is Denmark, Sweden, Norway, Iceland, and the Netherlands and France. The light orange countries are the ones where the regulations are planned to be implemented on all non-residential buildings. And the blue countries are the ones where the regulations are only implemented on public buildings. So now I will take you through the different LCA requirements from the Danish Building Code. And just to eliminate all confusions, the Danish Building Code is also called BR18. LCA stands for Life Cycle Assessment, which is an ISO standardized method for estimating the environmental impact of any given product system throughout its whole life cycle. And this life cycle, essentially, it's from cradle to grave. So that means from the extraction of resources until waste treatment. So this method, or the LCA, can be used to assess many different environmental impacts. So it can be CO2 emissions, it can be land use, it can be toxicity, and so on. But according to the Danish Building Code, we only have to assess CO2 emissions in our LCA, and also assuming that the lifespan of the building is 50 years. So what we're looking at here is the timeline of the Danish Building Code requirements. So these are focusing on buildings that are built after 2023. So the requirements are applicable from 2023. The LCA only takes into account the global warming potential, which is essentially the CO2 emissions, or the CO2 equivalent emissions coming from the building. So all buildings need to have an LCA when they are applying for a building permit, but only buildings that are above 1,000 square meters need to meet or be under a certain threshold. And the threshold is 12 kilograms CO2 equivalents per square meter per year as of right now. But as we will see later, this threshold will be revised. And in 2025, this threshold will also be extended to account or to include all buildings regardless of their size. So back to what the life cycle takes into account. When making an LCA of a product, the different life cycle stages are divided into different modules. And these modules are the ones we see here with a letter and a number. So it's A1, A2, it's B4, C3, and so on. What we see here is the modules that a building is divided into according to the ISO standards. And according to the Danish Building Code, we don't have to take all of the modules into our LCA calculations. We only need to include the ones that are marked with orange. So this is the production stage, which is the extraction of raw materials. It's the transportation of raw materials to manufacturing site, and then it's the conversion of raw materials to products. Then during the use stage, we need to include the replacement of building components over time, and we also need to include the energy consumption during the building, the use of the building. And for the end of life, we only need to account for the waste processing and the final disposal. And then we need to also include this module called Module D, which is the recycling potential, and it represents the potential future benefits of recycling. So it can be kind of hard to assess, and because our technologies and our recycling, the potentials for recycling constantly changes. But yeah, we have to implement that too. And in 2025, we also need to include the construction stage, which is the modules A4 and A5. So that's the transportation of products to the construction site, and it's the building process itself. Yeah, so now I have talked about requirements that are applicable from 2023, but I have also mentioned requirements that are applicable from 2025. And that's because the thresholds and the overall LCA requirements constantly gets revised. So what we're looking at here is the timeline of the initial plan of the involvement of the Danish climate legislation in the construction industry. So here the overall goal when moving towards 2029 is to reduce the total CO2 emissions by 70% compared to 1990. And to reach this goal, we progressively lower the emission thresholds for buildings. And as I talked about before, we can see that in 2023, the threshold is 12 kilograms CO2, but only for buildings above 1,000 square meters. And then the threshold is revised in 2025 and is 10.5 and includes all buildings regardless of their size. And again, in 2027, the threshold is lowered and so on. So when moving towards 2029 and with the LCA requirements becoming more and more comprehensive, the fraction of building projects that are affected by these regulations and requirements gets bigger, or say,
More and more buildings are affected by these demands.
Yeah, exactly. So we can see that in 2023, with the requirements that I have already told you about, only 10% of all the building projects were affected by the requirements. But in 2029, it's assessed that 90% of building projects will be affected by the requirements. So it's really, it goes to show that building projects and professionals need to meet the requirements sooner rather than later. Especially because the timeline we looked at before was the initial plan, and this is a new plan that's applicable from 2025. And with this new plan, the threshold not only is applied on all sizes of buildings or all building types, but we differentiate between the different building types. And the different building types have their own individual thresholds. So this means that vacation homes need to stay under a threshold of 4 CO2 equivalents, kilogram CO2 equivalents, and office building needs to stay under a threshold of 7.5. Or we can actually go to the next slide. So overall, these revised thresholds are lower than the initial threshold applicable from 2025.
So we were supposed to go from 12 today to 10.5, but now we're actually going to an average of 7.1. And for some building typologies, we're going all the way down to 4. So this is a major change coming in less than a year.
Yeah, it is. And it's very exciting to see how the building industry will meet these demands. And yeah, as I mentioned before, in 2025, we will need to include the modules, the life cycle stages A4 and A5. And that's what we can see here on this table. So this table shows the different life cycle stages that are implemented or planned to be implemented in the national building code among different Nordic countries. Even though Denmark still has a handful of modules that are still not required to be included in the LCA calculations, we are making significant progress compared to the other countries. As we can see, the other countries have either also already implemented the modules in their requirements or have planned to do it.
So Denmark is far in front in the European countries. As far as we know, it's also in front of all other countries. I don't think there's any country in the world with these strict regulations for all new builds.
Yeah. In the following, I will take you through the Danish building code specification. But first, I will quickly go through the first revision of the Danish building code involving the LCA requirements. So the key takeaways from this is that an LCA is mandatory for a building project when applying for a building permit after January 1st, 2023 to document an LCA, and it is the building owner who must document it, but it's not specified which disciplines has to calculate the LCA, nor is it specified which tools to use or how to document the LCA. It's just important that the documentation is easily understandable. Another requirement is that the LCA must follow the EN 15978, and this is the European standard that specifies the methods for calculating the environmental impact of a building. So that's an important requirement. And in addition to these requirements, the Danish building code has introduced some specific guidelines to ensure a consistent LCA calculation. So in the next 4 slides, I will show you some tables that are taken from the Danish building code. In the tables, there are guidance and examples that is supposed to help the industry professionals to calculate LCAs that are consistent and comparable. The first table provides information on whether or not a building component or building part should be included in the LCA calculations. For example, there are stairs, and they are supposed to be included in the LCA calculations. And then in the last column, there are details on when to include stairs and to what extent to include them. So, for example, stairs are only required to implement if they are a way of
Accessing the building.
accessing the building, or if it's a part of the defined building area. The next table provides an overview of standardized LCA data for different building materials. So normally, if you are a manufacturer of a product, you can make an EPD, which is an environmental product declaration of your product. And this EPD documents it's essentially an LCA, so it documents the environmental impact of this product from cradle to grave. But it's not at all the case that all products have this. So what the Danish building code has done is taken industry average data and provided the Danish building industry with like a list of building materials and their global warming potential in the different required life cycle stages. The next table is a lifetime table, and it lists the expected lifespan of different building types, different building components, and also materials. So that's also very important for streamlining the LCA calculations.
So normally when you want to do an LCA calculation, you need to get a lot of information on all the materials, all the products in the building. And that can be super time consuming, and often you run into products or materials that doesn't have any information available. So to make sure that everybody can do an LCA now that it's mandatory, then there's a list of generic data. So you can always just use the generic data and you don't have to get all these product specific EPDs and values.
So the last table here, or the last tables, emission factor tables. So these tables provide emission factors for different energy sources over time. And the emission factors are are based on projections from official energy forecasts. So they are especially relevant during the building use when calculating the environmental impact from ventilation and heating and all those things. Yes, and I will just, before Thomas takes over, I will go through the latest revision of the building code regarding the LCA requirements, and this is the one applicable from 2025. So it's still mandatory to document an LCA when applying for building permit, but now it's after June 1st, 2025. As I have already mentioned, the thresholds will now include all building types, but it will also differentiate, or there will be specific thresholds for different building types. We also need to implement the construction process, which was the modules A4 and A5, as I mentioned. And lastly, new materials, emission factors, and levels of details, like the ones we looked at in the tables before, have been added or maybe changed to be more accurate.
Perfect.
Thanks, Roberta. Can I just, we got a couple of questions.
Great.
First, it's my question. You said when you're applying the building permit, you get to present this to, I believe, some authority. What is it? The municipal? Is it something else? That where do you submit that?
You submit it, so it's to have the use permit. So it's not the initial permits, but the last use
Okay.
permit. You apply it to the municipality, and
Okay.
they look at your LCA calculation, and if they don't believe it, then they ask for more documentation until they believe that it's true. And if it seems there's some mistake, and you find out, oh, we are actually above 12 kilograms of CO2 per square meter per year, then you're not allowed to use the building. Then you have to change the building to have a lower LCA before you're allowed to use it. And nobody wants this. Nobody wants to have this headline in the newspapers that we spend so much CO2 on taking down half a building to rebuild it just to have a lower CO2 calculation. So therefore, a lot of municipalities are already asking for the building permit to see the initial work in progress LCA.
Thanks. And since it started in 2023, do you feel there's any economical impact on the construction in Denmark?
Not really. There has been an economical change because of the war in Ukraine, and we have a lack of workers, but not because of the new LCA demands and sustainability. If you want to do very sustainable changes, then it's going to be more expensive. But just to get below the threshold of 12, it's not that big a deal. It's not something that really changes the economy of the project. But we can see now that as more and more building owners want to go far below 12, we have heard building owners asking for 5 kilograms of CO2 per square meter per year. Then the consultants, architects and engineers needs to do a lot more work to make a building that is applicable for such a low calculation. And so on a building project, there will be a bigger part of the economy for architects and engineers, and also for these special developments if you want to get really low.
Thank you. There's a couple of questions. One of them, I believe you guys addressed it, which is, do suppliers in Denmark provide a CO2 emission score for their products, doors, windows, furniture, so that
Yes.
we can integrate it in the software?
Yeah, so they can choose to make an EPD or an LCA of their products, but it's not required, and that's why it's really nice that the Danish building code has provided some standard or industry average data for
Nice.
for us. Yeah.
But we see that there's a large demand on these EPD information, so most manufacturers are working on it. It's rather expensive to make these because they have to be certified by a third party. So it's not something you just do. If you're a window manufacturer, you actually have to do an EPD for each standard size of windows. So there's a lot of work with this, and they're complaining a lot, but they know they have to do it not to lose sales. And it's not implemented in the software right now, not in our software at least, but there are some different databases that have this EPD data. And the most used one is a Austrian database called Ökobau.dat, which is a free to use. And they have a lot of EPD data, which should be usable for all of Europe, and I think it would be useful for most of Canada and US too.
Thank you. I have like two questions, but I can merge them, I believe. But it starts with in the list of data material, is there data on reused or heritage materials? And the person is continuing with a different question. I understand that, I'm sorry, I'm reading it and it's quite long. I understand that all this is for new buildings. I was wondering if and how the EU building directives or the Danish building code favor the reuse and the renovation of existing buildings. Existing buildings and heritage buildings are lower in the embodied carbon in their LCA. However, the operational carbon will often be more significant, less performant walls, and often more carbon-intensive operational systems. Eventually, will the codes be applicable to existing buildings, and would there be an adjustment to ensure that they won't be demolished?
Okay, so I will try to see if I can communicate what I'm thinking here. But right now in Denmark, at least, the reuse of buildings and building components are a big theme, and there are a lot of discussions on how to manage the reuse of building components. Right now, I think it will be revised by 2025, but right now, when you use a reused product or a reused component in your building, it accounts for 0 CO2 kilograms. So that's, I think it's a way of saying, start using reused products in your buildings. We need to create some kind of market for it, because there is not incitament.
There's no push otherwise.
Yeah, because but to make an LCA, that's actually what I'm working on in my bachelor's. I have to make an LCA of a reused concrete element, and you have to make some rules on when does the life of the reused concrete element start and where does it end.
It's really complex.
Yeah, it's really complex, and it's a work in progress right now, but there is a lot of possibilities with.
So it's really a good question.
Yeah.
Because when these new demands started in 2023 in Denmark, the idea was if you had reused material, you should get a specific EPD for that reused material, but nobody had that. So the year after, in 2024, they said, okay, let's just set it to 0 and then try to push the industry to use more. But we know that we need to do more for refurbishing and rebuilding of existing buildings, but it's really difficult to set a threshold. It's easy to do the LCA, but it's difficult to set a threshold because there's a big difference between painting the walls and putting in new windows or converting an old industry building to new apartments. that would never be the same threshold they would be under. So right now, that's why it's easier just to do new builds than renovations. Yeah.
Thank you very much. It was a very nice question, very interesting. Thank you. Please keep on sending those questions, and we will address them at a certain point.
Definitely.
All right.
Yeah.
All right.
I'll continue. So Alberta already told us that 30% of the Danish CO2 footprint is from the AC industry, but what not very many people know is 1/3 of that is material use and 2/3 of that is the energy for operations. So right now, the architects often look to new materials that is more sustainable, but what they perhaps should do more is to look at how to make energy renovations of buildings or make them use less energy. And if we compare two kind of projects, both of them are DGNB certified. That compares to LEED or BREEAM in North America. Then 25% on an average concrete apartment project would be the operational energy, and 75% would be the material use. If you make the same kind of project, but with a wooden structure, then 60% would be material CO2 and 40% would be the operational energy. So these percentages, they change when the total size of carbon changes. The problem is in Denmark that we're allowed to use a state-provided, a public-provided energy calculating method, which is the orange boxes here. And they calculate energy in a wrong method. So it's way too low values. If you look at the blue box, that's the actual energy use of buildings. So when we calculate in Denmark, we only calculate kind of half the real use. And therefore, if you try to calculate the real use, and actually 60% of the energy of the CO2 is from the energy for use, and only 40% is materials. So my personal point is that we should much more try to balance the view between material use and the energy. And we cannot just add more insulation and more layers of glass because we already reached the maximum capacity of that. It doesn't, often in Denmark, we have 30 centimeters of insulation, and it doesn't help to get 35. So we need to change the design of the building, the size of the windows, the placement of glass, to make this better. And for that, LCA is a perfect method. So right now, there's a lot of different tools. Some of these are Danish, some of these are international. The most known is probably One-Click LCA, and that's a web-based product, and it's really good. You can do all kinds of LCAs, also just for greenhouse emissions on buildings. Ours is called Design LCA, and we of course think it's the best one at all. And then LCA Byg, which is the governmental provided free LCA calculator, which is more or less a huge spreadsheet where you just enter all the quantities, add all the EPD data, and then do the calculation in the end. So we're gonna focus a little bit on Design LCA to show you how that works. In Denmark, we have a website that shows all the different LCA tools, so people get a chance to compare the different tools, find out which one suits their wallet and their needs and their expertise. And that's really clever when we have these demands in the country. So our approach, being a BIM provider, is of course that LCA should be done within BIM. So it's a very strict BIM tool, but it's also a very easy tool. So where some other solutions can do all kinds of LCAs and all kinds of scenarios, our will just calculate the CO2 from the building you model in BIM. If you don't model it, it's not calculated. So that's kind of an easy way. The reason we started with this project 2.5 years ago was because one of our customers using Archicad was at a training, and they asked, with all this information within BIM, wouldn't it make sense to do LCA calculations directly in BIM? and we had no clue this was possible. But then we figured out it's actually not that difficult a task to do it inside the BIM application. Then we worked together with a Danish known company called Linear, an architect office, which do very sustainable buildings and focus a lot of upcycling. And we did a few different projects. This one is a competition project in Germany to try to test if this works. And what they found out was, if you want to do LCA in a way that's not just documenting something you already have drawn and modeled and designed in the end of the process, if you want to use it as a design tool, you need to do this in the architect office in the early stages while you test something. You cannot have the engineer working in parallel at that phase, because that would make a lot of calculating by the engineering office, and that would be very expensive and time consuming. So the architects need to be able to do this themselves from the early stages. And with design LCA, now Linear can do this themselves, and they say now LCA has become a design parameter in their work. So every time they decide something, one of the key parameters is how this performs with a carbon footprint. And on the technical side, it's just a dashboard that every time you model something, you can see how it affects the CO2 footprint of the building for the first 50 years. Design LCA is a free plugin, so everybody can just download it. It works for Archicad. Oh, sorry. It works for Archicad 26 and later. It fulfills the requirements of the Danish building codes, but also the ISO standard of LCA. So it works all over the world. In Denmark, we deliver it together with a template where we have all the generic data from the Danish building codes. So it's much easier to use this in Denmark because we have all this data included. In other countries, you need to find the EPDs or use an EPD database, and you have to make these different building materials by yourself because Danish generic data might not be applicable in other regions of the world. But I know that some BIM providers are providing a template which have LCA data or CO2 data included for design LCA. And then everything is done inside Archicad, and we're the only software for LCA calculations, as far as we know, that can include both CO2 from the material use and CO2 from the energy for operations. So that's the special thing about design LCA. So I'm going to show you the first of 3 videos, and this one is a time lapse of the whole workflow using design LCA. So you just open your BIM application, you open Archicad, and you start modeling. And I'm an architect, so when I start modeling, I have no clue what materials the building would consist of. So it's just gray. And at some point, I need to add materials, not because I need to know what it's built of, because I want to do visualizing, and then I need some materials on the facades. So I think we also need a roof. But after the roof, I will pick all the walls of the project and add a composite material, so a layered material with one click. So now pick the walls, pick the walls, pick the walls, and change, and pick the slabs and change. And you can see the layers on the slabs, but I don't want to show this, so I just model some kind of material around these slabs, and then I add foundation. And later on, I'm going to change this project to a wooden structure, and then the concrete foundation will still be concrete. So this actually has a big impact on the project. Then I model some kind of gateway to the building, and that's not supposed to be included in my LCA. So the reason I model it now is to show later on that I'm going to exclude it from the LCA calculation. So now I think I'm ready to add my rooms to the project, and to have Archicad understand the outer perimeter of the building. and understand how many square meters it is, I need to have rooms inside, BIM objects for rooms inside my building. And therefore, I might as well add the internal walls. But also when I have a 2-story building, it makes sense to add the staircase, as I do here. But more importantly, to cut the hole in the slab, because then I don't use too much CO2 on something that's taken away later on. So there's some kind of detail level that is the optimal detail level for an LCA calculation. And that's what I'm trying to show with this video, the sweet spot for modeling. And I think now I've done the staircase. So the Revit users out there, I know using Revit, it will take much longer to do the staircase, but in the end, it's more or less the same we do. So now I can just stamp out the rooms in the building. And that's the last part of the modeling. It needs to show the parameters of the building. So I need to cut the rooms with the roof, so it knows all about where the end of the building is. And this is the section that shows the sweet spot of the detail level for a model that's really good for LCA calculation. So that's the end of modeling. So now let's start calculating. So I open up the Design LCA dashboard. I can see the settings here. And then I can see there's 80,000 kilograms of CO2 on this project. I can see the different materials, they have CO2 values, but now I need to do an energy calculation for the operational energy of the building. So I add all my rooms to what is called a thermal block, and I assign some different building systems for heating, cooling, and ventilation to this thermal block. And then I say it's apartments. So there's a special use case here. Then by standard, it's the center of Copenhagen, but I can change that to anywhere in the world. And Archicad will automatically download the weather data for this area. I can adjust the heating systems or the building systems, and I can add solar panels. But if I add the solar panels here, I need to know exactly how big they are and which angle they're placed. So I don't want to do that here. I want to do that later on. Archicad knows all the different building materials, so it will automatically calculate the U values for slabs, walls, and roofs. And for doors and windows, I have to help it a little bit by saying the frame of the door and window is wood. There's so many layers of glass, this door material is used, and then it will calculate the U value. And now I'm ready to do the report of the energy, but I don't need the report. I just need to send the result to Design LCA. And right now you can see the blue pie part, the blue part of the pie chart is the energy use, the orange is the materials. And now I can change from 17 kilograms of CO2 per square meter to a wooden construction that only has about 15.7. So I have several kilograms per square meters less CO2 by changing from concrete and bricks down to woods. Then I can detail the materials for my windows and my doors. So before we were looking at the U values, now we're looking at the material use. And by detailing those, the result changes to 14.8, I think. Very small numbers. So let's look at the materials, and I can see there's something in the terrain that shouldn't be included. So I can, on object level, exclude it, and now I can see it's 0. So where can I get the biggest benefit? On my outer walls, there's a lot of gypsum with a CO2 footprint. So I just delete one layer of gypsum, and now I'm down to 13.4, I think. Let's look at the inner walls, internal walls, partition walls. They also have gypsum. I cannot just delete that, so I'm changing that to some plywood and some wooden insulation. And now I'm down to 12.4. I'm getting so close to this 12 mark. And in Denmark, we have generic values for the installation material use. So I can just add that as a square meter value. And now I'm down to 11.9, and I reach my goal. I'm less than 12. So I want to prove this by stamping down the LCA calculation on my plan drawing. But we also did layouts or sheets in the template in Denmark that would do the documentation for the LCA. So that's it. But unfortunately, being an architect, I need to change the project all the time, just because I can. So I just changed the pitch of the roof, so I have more roof material, but I also have a lot of more wall material. I changed the size of the windows, so they're bigger. And now I changed the whole size of the building, so I have more floor size. And to do the calculation now, I have to redo the energy calculation. But I already did all the settings, so I just need to update it and send it to Design.ca. And over here, I just press update. And now I can see I'm on 13.6, I think. So I need to, with this new design, I need to do something else to get to a lower LCA calculation. So that's more or less the whole process for LCA calculation. If you are a Revit user, then you can still use Design LCA within Archicad by exchanging IFC files. So this is inside Revit. And if you want to do a sketch project, this is a perfect detail level. No information about materials inside Revit. So you just have massive walls with windows, doors, roofs, slabs. You also have room tags inside the building. You import into Archicad. First, we have to extend the size of the rooms and cut them with the roof. So we have a volume defining the outer perimeter of the building. And then I just change the different element types one by one. Let's do the walls first, change them to a composite in Archicad, this layered structure. Then I change the roof, and then I slowly do all the changes of materials until I'm ready to do the LCA calculation. So this is not something that takes up a lot of time inside Archicad if you have the model from Revit. If you're on a later phase in Revit, then you do an IFC like this that has all the layered materials already in the model. This is just an IFC viewer. So I'm just looking at my project. But instead of importing the IFC into Archicad, I just want to do a translator for the import. And here I point to the IFC file. I get all the materials in a list, and I can map each material one by one to an Archicad material. So the Revit material mapped to an Archicad material. I press save on the translator. And this translator I can use every time I import an IFC with the same materials. And then the materials are automatically translated into Archicad materials. So the only thing I need to do now before making the LCA calculation is adjust my doors and windows, do the energy calculation, and I'm done. So the fastest way to do an LCA calculation in Revit is to use Archicad and Design LCA. Of course, there's also many other tools you can use. They're just not as fast. So this was kind of our pitch about why LCA is a really good way of estimating the environmental footprint of a building. Using Design LCA, it's a free add-on for Archicad. It works in the early phases. It works in the later phases. The more you model, the more detailed your model is, the more detailed the LCA will be. If you use the Danish template in Denmark, you have all the values from the Danish building codes. But in other countries, you just get the plugin and the calculator, and you have to add the CO2 values to the materials. You can save that as your own template, and then it also works with no extra views.
Yeah.
So
Thanks, Thomas. We're running out of time, so
I know. I just want to
but,
point on the URL. So if you go to designlca.com, you can get your own free copy of Design LCA.
Thank you. And it's integrated inside of Archicad. So I'm gonna ask. There's somebody who raised the hand. I'm gonna ask him to ask his question.
Perfect.
Can you unmute?
It looks like a French name, so I hope the question is not.
Jean-Michel, yeah. Can you unmute? Okay, while Jean-Michel is... Jean-Michel, can you talk right now?
Yeah, hi, I'm sorry, it was just a mistake, but it's very interesting.
Perfect.
No problem. So we have just one time for one last question that was here, but it's about the regulations of and calculations. How do they affect architectural quality?
So that's also a really good question, and I think that we could discuss that for a long time. So I know before these rules were effective in Denmark, architects were saying we are already sustainable. Some said that the most sustainable buildings are beautiful buildings because they will be standing there for many years. So as architects, we do sustainable buildings because we do beautiful buildings. But after these regulations have been set into effect, we can see that now it's really changing. The way we build is really changing. And I think a lot of projects are more beautiful. I think we're getting back to some old ways of using other kind of materials like wood in new ways. So we're kind of reimagining the old standards of building. And I think there's so many beautiful and really tactile. It's a new way of architecture, and I think it's better. There's also, if you look at upcycling as a part of this sustainability theme, then you get something that looks a little bit more like small parts taken from all over the world and put together into new buildings. And I think that kind of reuse is also beautiful in its own way. But I remember when I saw these buildings for the first time a few years ago, I thought, oh, it's not beautiful, but it's probably sustainable. And now I more and more like the aesthetics of these sustainable buildings. I hope that's an answer.
That Thomas and Albert. That's all we have time for. And thanks everybody that attended for this webinar. And we'll be doing other activities pretty soon. Thanks a lot.
Thanks for having me.
Thank you.